This is practice problem number 4, lesson 14, solving more systems, and unit 4, linear equations and linear systems. In problem number 4, you have a system of these two equations, x minus 6y equals 4 and 3x minus 18y equals 4. And this system has no solutions. So when you see that a system has no solutions, you have to think of two things. One is that the graphs of these two equations are parallel. So the lines are parallel, they never intersect, and they have a different y-intercept. So they cross the y-axis at different places. So they never intersect, they don't have a solution. So parallel lines, that means that they have the same slope, and that's the coefficient. So we're going to talk about constants and coefficients down here in the questions. And the same slope has to do with these two coefficients, the coefficient of x and the coefficient of y in both cases. So there are actually 4 coefficients. And then different y-intercepts, that has to do with the constant term, this 4. But that's not the y-intercept. So these two equations are written in standard form. So let's review what this means just for a second. So if you have two equations written in standard form, so this is a standard form right here, and if you remember, it's ax plus by, so a is 1, b is negative 6, equals c, which is 4. Over here, a is 3, b is a negative 18, and c is 4. So if you were to change the standard form into the slope y-intercept form, what that means is you're going to get this y term by itself. So you're going to write an expression that is equal to y by moving everything over to the right side of the equation and leaving just a single y on the left side. Well, to do that, you move this 1x over to the other side. So this becomes a negative 1x. It's right here. So the beginning of looking at the standard form and realizing what the slope is to realize that it's the opposite of the a term. So it's the opposite of a, so the opposite of 1 is negative 1, and that gets then divided by the b term, negative 6, or the b coefficient, negative 6. So a, the opposite of a, which is negative 1 right here, divided by b, which is negative 6 right here. So negative 1 divided by negative 6 is equal to 1/6, and the slope then is 1/6. And remember, slope-intercept form, this is y equals mx, and that m is the slope, mx plus b, and b is the y-intercept. We'll get to that in a second. Over here, the slope is the opposite of a, which is negative 3. So see how this 3x ends up on the other side of the equal sign, so it becomes a negative 3x. So it's the opposite of a divided by b, negative 18, because you're going to divide through by negative 18 to get this y term by itself. And so this equals y equals, and 3/18 simplifies to 1/6. So these are equivalent fractions, 1/6 and 3/18. And we'll come back to that in a few moments as well. And you add to that the y-intercept, which in this case is a negative 4/18. So the y-intercept is c, the 4 in both cases, but that gets divided by b, which is negative 6. So 4 divided by negative 6 is a negative 2/3. So this equation has a slope of 1/6 and a y-intercept of negative 2/3. This equation has a slope of 1/6 also, so it's the same slope, parallel lines, but different y-intercepts. This y-intercept is a negative 2/9. So when you see this, it says change one constant or coefficient to make a new system with one solution. One solution means that the slopes are different. So we're going to change the coefficient. We need to change the slopes. This is 1/6, and this is 3/18, or 1/6 also. Remember, it's a negative 1 divided by negative 6, 1/6, and a negative 3 divided by negative 18, also 1/6. So we can change any of these coefficients and we will change the slope. Once you change the slope, the lines, the graphs will intersect, and they will have one solution. So let's just look at the meaning of the word coefficient for just a second. This is a QR code that takes you to this page. And I read through this, and I can reduce this paragraph down to really this sentence down here. So coefficient means that it's two things. So co is two things that are joined together to make the effect, which is the result, the effect better or more efficient. So effect and efficient come from the same root word, and that's what this says up here, which actually is exit. The word is exit. So the coefficient means the value that's written with the variable. So that's two things, the variable and that number. It's the number of times that you have that variable. They are joined together to make the result, to make their meaning more efficient. So it becomes the word coefficient. So coefficient. And in B, you're going to change one constant. So now this is a term that never changes. So this 4, regardless of the values of x and y in each equation, never changes. That combination of the value of x and the value of y combined together in this operation always equals 4. In this case, different coefficients, but they always come together to equal the same constant, 4. So in the second part, B, let's change one constant or coefficient. So I underline constant because you're going to change the y-intercept to make these two equations the same equations. So if a system of equations has an infinite number of solutions, what that means is that the equations are written in different forms, although those are equivalent forms, like equivalent fractions. We talked about that just a moment ago. 1/6 and 3/18 are equivalent fractions. So it's the same idea. You're going to write equivalent equations, but just in a different form. So same slope and same y-intercept. So there's a lot going on in this problem. So a little review, once again, of the standard form, ax plus by equals c. And the slope is the opposite of a divided by b. Remember, this a is going to end up on the other side of the equal sign. So it's going to be a negative a divided by whatever the value of b is. One solution. So in a, there's one solution. So we're going to change the slope, change one coefficient so that it has, so the two graphs intersect or have one solution. For b, an infinite number of solutions, so we're going to make the constant the same. So we're going to look at two equations up here. We're going to change just one of these constants. We're going to end up with the same equation. So when you figure out the y-intercept, that will be c divided by b. It will be the same for both. All right, so for 1, the slope is the opposite of 1 divided by -6, which equals 1/6. For 2, up here, 3x plus a -18y, so it's the opposite of 3a divided by b, -18, which is a positive 3/18, which is also 1/6. The y-intercept, which is the constant, that is c divided by b. So this c term gets divided by b because you're going to divide through by -6 in this case to get rid of the -6, because you want to get y equals an expression on the right. You're going to divide through by -18 to get this y by itself. So you're going to end up with c, the y-intercept is 4. C is not the y-intercept, but you're going to end up with the y-intercept, which is c, 4 divided by -18. So 4 divided by -6 equals -2/3, and 4 divided by -18 simplifies to -2/9. So it makes it a little bit easier to look at the graphs for these equations and make these changes to see what happens to the graphs. So in this case, 1 and 2 are the original two equations. So I'm going to graph both of those. So this is graph number 1, is this red graph down here, has a y-intercept of a negative 2/3. So 3 grid lines are equal to 1. So 1/3, 2/3, 3/3 is 1, negative 1/3, negative 2/3, negative 3/3 is negative 1. So that y-intercept for this graph is negative 2/3, which is 4 divided by negative 6, and the slope is 1/6. So for every 6 units along the x-axis, so count out 6, 1, 2, 3, 4, 5, 6, this graph goes up 1 unit. So this is 1/3, 2/3, 3/3, or 1 unit. For 2, the y-intercept is a negative 2/9. So different y-intercepts, negative 2/9. It's this 4 divided by this negative 18 simplifies to negative 2/9. Well, 2/9 is 2/3 of 1/3. So 2/3 times 1/3 equals 2/9. So you can see that this is 2/3 of this 1/3 right here. So this is negative 2/9, but it also has a slope of 1/6. So 6 units along the x-axis. This is 1, 2, 3, 4, 5, and 6. And then it goes up 1 unit. So the slopes are the same. So these two graphs will never intersect. All right, so we're going to make a change. We're going to change this coefficient of x, 1 to 2. So this is going to change the slope. So if I change this 1 to a 2, this slope becomes now the opposite of a, or the opposite of 2 is a negative 2 divided by a negative 6, which is 2/6, which is now 1/3. So this slope has changed from 1/6 to 2/6. 2/6 is 1/3. So 1/3 is twice as much as 1/6. So this graph increases at twice the rate of graph number 2 or graph number 3 for that matter. So now if I compare, I've changed 1 to 3. So I've changed 1 to 3. So now they have different slopes, 1/6 and 2/6, and 2/6 is equal to 1/3. And so now they intersect at this point right here, which is 8/3, 2/9. So now this graph, 3, is the result of changing one coefficient. So I've done what it says in A, change one coefficient so that there's one solution, which is this point of intersection. And you can tell it's 8/3. You can actually see that from the graph. This is 1, 2, which is 6/3, 7/3, 8/3. And if you take that 8/3 and replace it in equation 2 here, 8/3 times 3 is 8. So this becomes a negative 8 plus 4 is a negative 4. And so negative 4 divided by negative 18 is a positive 2/9. 4/18 is 2/9. So if you go through the arithmetic, you'll see that y is 2/9. Okay, so that's part A. Part B, I'm going to change one constant so that there's an infinite number of solutions. Basically, they're going to become graphs, the same graphs, but the equations are going to be really equivalent equations just written in a different form. So what I'm going to do is multiply through by 3. I can see that 3 times 1 is 3x, 3 times a negative 6 is a negative 18x, and 3 times 4 is 12. So now, if I change this constant term right here, 4, to 12, which is what this is doing, then I'm going to have the same equation. I'm going to have this equation is equivalent to equation number 1. It's just written in a different form. It's a multiple. It's multiplied. Each term is multiplied by 3. So it's kind of convoluted. I'm actually changing equation 1, but the net result is to change equation 2, change this constant term, which is what the question asked for, from 4 to 12. All right, so compare 1, 1, and 4. So this is 1 right here, and you're going to see that 4, 1 and 4 are the same graph. The slope and the y-intercept, each term in 1 is multiplied by 3, to get to 4. Each term in 1 is multiplied by 3 to get to 4. And so that is now like taking equation 2. So now compare it to 2. That's like taking this equation 2, changing this term to 12. And so that makes this y-intercept a negative 12/18, which is a negative 2/3. So in effect, you're sliding this line, this graph, down to right on top of number 1. So it has an infinite number of solutions. So it's the same graph, but different yet equivalent equation. A little bit hard to look at, a little bit hard to think about. So for A, we changed the coefficient from 1 to 2. For B, we changed the constant from 4 to 12. But we did that through looking at equation 1 and multiplying each term of equation 1 by 3. So we made equivalent equations. All right, now, this is a review of what we talked about before. I could have just changed everything to the standard form, to the y-intercept form, and then changed the coefficient from 1/6 to 2/6. So this is now 1/3. So that's what, in effect, what I did. This would be a much simpler way to do the problem, but this isn't what the authors are getting at. They don't want you to go through this path of rewrite it in the y-intercept form. They want you to work with the standard form and recognize what the coefficients are and the constants are. But if I change the coefficient in this case to 2/6, that changes the slope. And for B, this is the y-intercept, this is the y-intercept. So if I change this y-intercept to the same y-intercept over here, negative 2/3, then this equation then will match this equation, so they'll have an infinite number of solutions. Now, rather than changing equation number 1 to equation number 2 by multiplying each term by 3, so 3x minus 18y would equal 12. So I changed this constant here. I could divide each term by 3 or multiply each term by 1/3. It's the same thing. So 1/3 of 3x is x. 1/3 of 18 is 6. So this becomes x minus 6y equals, and 1/3 of 4 is 4/3. And then if you figure out what the y-intercept is for this equation now, that's been multiplied by 1/3, it would be 4/3. So the C term divided by B, which is negative 6. Well, 4/3 divided by negative 6 is the same as 4/3 times a negative 1/6. Do that calculation, you get a negative 4/18. And you see that that's the same y-intercept as the equation number 2, which is C4 divided by negative 18, which is a negative 4/18. So this is the y-intercept, and this is the y-intercept. So these two equations then are equal, just written in different forms, and they have an infinite number of solutions. So now this is like sliding graph number 1 up to match graph number 2.